All right, this lesson is called Trig substitutions. It's kind of one of our last remaining ways to go ahead and do some antiderivatives, finding antiderivatives. We haven't quite learned all those methods yet. It's pretty straightforward. We're looking for certain things, what we call certain patterns. So if in an integral you see any of these three patterns, this little trick here is telling you what to substitute. It's kind of like a u sub, or actually kind of like integration by parts also. We're going to let x equal something, whereas at u sub we let u equal to something. Integration by parts, we let, remember, we picked a u and a dv, so we're going to actually pick something for x. So if you see something that looks like the square root of a squared minus x squared, you're going to let x equal a sine theta. And you'll see an example work here in just a second as to why this works. It's nice little using trigonometric identities to make it work. If you see a squared plus x squared, you let x equal a tangent theta. And if you see square root of x squared minus a squared, you let x equal a secant theta. A couple things. It's written as a squared, like it has to be a perfect square, like 9 or 16. It doesn't really have to be. It could be 5. If this is 5, if that number was 5 minus x squared, then your a would be square root of 5. If it's 25, then it's going to be 5, of course. Also, the square roots do not have to be there. These patterns will work even without the square roots. The square roots are a nice little addition. We're going to wind up taking the square root of something. It's going to work out nicely, you'll see. But even if the square root's not there, this method will still work. So I'm going to send you these also. You'll get the same printout. But let me do 3 examples here, a couple examples, and we'll go from there. Give me 1 second. So the first integral is 1 over x squared times the square root of 4 minus x squared dx. So notice this looks like other integrals we've done. You might look for other things. You might do a u sub. You might do integration by parts. These things could work also. But if you see that little factoring pattern, not really factoring, but that little pattern that I just mentioned, that square root of a squared minus x squared, this trig sub will work. So if you think about the a squared minus x squared being 4 minus x squared, your substitution that you're going to make is called a trig sub. We're using a trig identity for this to work. Is going to be x equals 2 sine theta. We're using sine because of the a squared minus x squared, and the square root of 4 is 2. So now we're just going to substitute. So if x is 2 sine theta, that means dx. We take the derivative of this. It's going to be 2. The derivative of sine is cosine theta d theta. So now we're just going to substitute these parts into here for all other x's and all our dx's. So that dx is going to become a 2, pen here, is going to become a 2 cosine theta d theta. That's my dx. My x is the 2 sine theta. So that's going to be x squared. So it's going to be 4 sine squared theta. And then this, here's the whole trick to this is going to work out really nicely. If I do this substitution, I get 4 minus x squared, which should be 4 sine squared theta. The reason this identity works, or this substitution works, is because what's going to happen right here. So we're going to simplify that, and we're going to get 2 cosine theta d theta. On the bottom here, we still have 4 sine squared theta. This, factor out the 4. I'm going to do this in 2 steps, 1 quick step if that's all right. Factor out the 4, you're going to get 1 minus sine squared. But 1 minus sine squared, I'll write it all out for you. So 1 minus sine squared. But remember that 1 minus sine squared is like cosine squared. So we get 2 cosine theta d theta over 4 sine squared theta. This is 1 minus sine squared is a cosine squared. So 4 cosine squared, square root of that is 2 cosine theta. So notice that square root was handy because we could take the square root of that work, but even without the square root, it's still going to work. Now there should be some simplifying. Now we just have a whole new integral to find. It's going to have trig stuff in it. So you might see some of those trig methods that we learned a few chapters back. I'm going to do some simplifying. 2's gone, cosine theta. I'm going to factor out that 1/4, and I'm just left with d theta over sine squared. So you have to try to figure out all our old methods for doing those. It's a really simple one because 1 over sine squared is a cosecant squared. So now we can integrate the cosecant squared. So the trick to any of these problems, we're going to do substitutions, going to work on that, so you're going to get something new right here. And then you have to use your old methods at this point to figure out these intervals. This is straightforward because the antiderivative of cosecant squared, or the derivative of tangent, cotangent is a cosecant squared. So this would be 1/4 negative because the derivative of cotangent is a cosecant squared, right? Plus c. So it looks like we're done, but not quite, because we have thetas in my final answer, right? So with thetas in the final answer, we have to go back and do our little substitution. So what you do is just go back and draw a little triangle of this x equals 2 sine theta, which also means sine theta equals x over 2. So if you put your theta here, sine is opposite over hypotenuse, which makes the adjacent 4 minus x squared. So now you can find any of the trig functions, right? So we want cotangent. So cotangent is reciprocal tangent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. So we just come back and fill that in. Adjacent over opposite. And we get the square root. My adjacent is 4 minus x squared over my opposite, which is x plus c. And there you go. Quick little check and make sure I got it right, which I think I did. And there's your final answer. Put that up there for a second. I'll do one more for you. A second. Let's do a plus 1 over the square root of 4 plus x squared. So again, remember any of these, you're just looking for that little identity that you can use. Remember, you could still try other things, right? If there happened to be an x on top, this method will work. The trig sub will work, but it's going to take you a lot longer than if you just said, hey, look, u equals 4 plus x squared, du is 2x dx, that x will cancel that x. It'll be a lot simpler. The trig sub will work, but it'll just take you a little bit longer. Keep an eye out for those things, because you might see other things that happen. So notice I have an a squared plus x squared. So I think on the a squared plus x squared, you let x equal to a tangent theta, right? In this case, my a squared is 4, so my a is 2, which means my dx is the derivative of tangent, which is secant squared theta d theta. Now we substitute the x is 2 tangent theta. The dx is 2 secant squared theta d theta. At the bottom, I got a square root of 4 plus x squared, which is 4 tangent squared theta. So we simplify 2 tangent theta times 2 secant squared theta d theta. I'm going to do some one step. If I factor out that 4, I get 1 plus tangent squared. That tangent squared is the secant squared. So 4 secant squared, and the square root of that is 2 secant theta. So again, the square root, didn't really need it. It just made this a little bit simpler. So let's see, 2, 2, so I got a 2. One of those secants is gone, so I got a tangent theta left over and 1 secant theta. So again, at this point, anything could happen. You might have to do pulling out a secant tangent, you might remember those, or pulling out a sine and cosine. This is a simple one, because the antiderivative of secant tangent is secant theta. we're at the same point, remember we're at theta. So we go back, we draw my little triangle, come down here. Tangent theta equals x over 2. So tangent is opposite over adjacent, which makes this a 4 plus x squared. Now you can do any trig function. We want secant, which is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So this will be hypotenuse over adjacent. So 2 times 4 plus x squared over the adjacent, which is 2. So the square root of 4 plus x squared plus some constant c. That's trig subs in a nutshell. You're just looking for the proper substitution and going from there. So that's it. Hopefully that helps. I'll be back tomorrow to answer your questions.